Hi there friends, and today I have something really cool I want to show you. I combined my three favorite detectors into one machine that serves one purpose. So let's show you exactly what I'm talking about. So this is the current state of my empire of nuclear chaos, and let me show you what I built here. This here is the Muon detector for Cosmic Ray Muons. Well, this is just the computer box. Here we have the two Geiger tubes that connect to the Cosmic Ray detector. Over here we have the Cloud Chamber Particle Detector. This shows you charged particles. And up here I have my favorite photon detector, just a DSLR camera. And what is happening here is that if a Cosmic Ray Muon comes flying from this trajectory, passes both tubes of the Muon detector, the Muon detector will give out a signal through this wire over this little transistor. I'll show you in a moment what this here does. This goes up here to the camera and triggers the camera exactly in the moment, or yeah, maybe with a little bit of a delay, when the cosmic ray passes through both tubes, and eventually it will fly through the cloud chamber in a good angle that we can see a track of the cosmic ray. And because the tracks in the cloud chamber, they have a little bit of a delay anyway, they just hang around for a tenth of a second or so. That delay is enough for the whole electronic delay here for the camera to trigger in the right moment. So I can do Muon selfies now. Or actually, better said, the Muons do their own selfies. They take pictures of themselves. How awesome is that? Okay, just some words how I built the circuit before I explain you more. There would also be a possibility to do this controlling the camera via the Raspberry Pi mini computer that's down here. But I figured out I'm just more the analog than the digital guy. I don't really do programming. It would be quite easy. You even get a Raspberry Pi camera you could connect directly and do it this way. I have one of those cameras, as you see, but then I was like, this camera or this camera? Oh, I'll go for this one. I think that will make better pictures. So that's why I did it analog, and I kind of hacked the trigger of the camera to work with the Muon detector. Well, this thing here is the core piece of the Muon detector. That's a little Nucleo 32 microcontroller. It's something like an Arduino. And the point is, you have a lot of these pins here. I think there's like 15 on every side. And they do stuff. And down here on the motherboard, maybe we can see it. Where are the LEDs? Yeah, down here there's one. Yeah, you see two LEDs flashing. They actually flash yellow every time one single Geiger tube fires. But they're double LEDs, and they have I think it's blue, the second color, that lets both of them flash at the same time when a muon hits. And we have a pin out here, I think it's this one here, that's actually connected with the power supply of those LEDs. So I took this pin out to make a small circuit to trigger the camera. The circuit, if you're interested, would be this one. I'm not good in drawing circuits. I'm generally bad in electronics, but this here kind of worked. If you want to like reconstruct it, I hope this is some help to you. I just go over a small transistor and make like a short circuit to trigger the camera. So basically it's these two cables here coming out. Here's the transistor, here the wire goes up into the camera. That's how the whole setup works. Maybe some words to the Muon detector. I chose to take the big tube assembly for this experiment. I tried it with the small tubes too, with these here, but they're quite a bit smaller. And I think with these here, your results will be a bit more precise, but you will wait much longer till you get results. With the big tubes, the camera misfires quite a lot. Like I have 1 muon per 50 pictures or so. So I still have to sort out a lot, but I'm still very happy that it works. And it's really an autonomous system that lets cosmic rays take pictures of themselves. Also, one little thing that I changed, I do not use the LED gamma ray filter. Normally I would have this here in between. I think it would actually work with the filter, but I rather risk to get a lot of false positives, to get a lot of false pictures with no muons on them, because I just can sort them out on the computer. That's not a big deal. I prefer it this way. I think I have more chances to really get muons on camera this way. Well, the muon detector is running and giving signal to the camera. The camera is also running and in focus and everything is ready. Now I only have to start the cloud chamber, so let's do that now. Turn on the fan. Turn on the Peltier coolers and the electric field. Yeah, now it's running. Let's wait a few minutes and the thing should be working now. So the whole setup is running and working now. And let's see, I doubt that we get a muon on the video camera and on the photographic camera at the same time, but just about angles, like let's imagine this wire here is the trajectory of a muon. We will have a lot of false fires. Let's say it passes through here, then it just misses the cloud chamber. Or also like this way it would miss. The angle can be up and down to a tiny bit, so it really has to be perfect. That's why I only get like one good shot in about 50 pictures. But I'm still very happy, and it works great. It's an awesome combination of 3 devices to make one purpose. Let's just wait a little bit just to see the camera firing. It's always total coincidence when the muons will hit. We should have like around maybe 1 per minute, something like that, in this setup. Ah, there we go. So yeah, it's working. I'll show you some of the pictures that I made so far. It took me about 1 day to take all of these, but let's move to a quieter room for that. Well, this is a picture of the setup, just about the angles, how I set up the camera and the tubes. I did change the angles quite a bit, so all the pictures look a little bit different. But just for the first one, this is the top view. You see the Geiger tubes on the left and the cloud chamber in the center. If we zoom in and we actually have a muon track here, this is a successful shot. You see the little white track here, and this is the explanation what's happening here. I just made a little graphic how the tubes would be assembled and from which direction the muon actually came. So let's look at some other ones. This one is actually the best one I think so far. It's almost a straight line. It's almost crossing the entire cloud chamber. Put a little arrow here that you see it. Yeah, it's coming from this direction. Then there is another one. This is really weak. You hardly can see it, but it's also a straight line. Put the little arrow here that you can see from which direction it's coming. This one here is quite good too. Probably came in an angle, that's why it didn't cross the whole cloud chamber. Also a little arrow, there you go. This one is a bit not so good, but it's still there, it's visible, it's a confirmed muon as well. Yeah, I guess that's it for now. I'll work on some new muon pictures, maybe I'll get some better ones. Just in general, this is not so much aesthetically beautiful like the uranium ore in the cloud chamber, for example. I mean, this looks really beautiful and it's a video, you really see what's going on. Pictures are a bit more difficult of cloud chambers, I think, or that's my experience at least. There's just little lines, but the awesome thing is that I really can build a machine that lets cosmic rays take pictures of themselves. I'm very happy about that. It's a really cool project, I think. So let me know what you think about it. Maybe you did something similar or so. Give me the information, I would like to see it. And in general, if you liked my video, please like and subscribe as always, and see you soon for further experiments. Bye!